Hi there once again. I'm sorry I had to cut off abruptly there in the previous video because I ran out of my allotted time. I could only put videos that are 15 minutes long, so I ran over it. So my apologies. This video is a third part. We'll look at the last section where you use differentiation to solve some practical problems. Okay. All right. So let's start. I'll give an example like this. Okay. So you have fencing that has a length of 16 meters. All right, so you have fencing that has a length of 16 meters. Okay, so you have got to create an area on a field using this fencing. Okay, a rectangular area that would have the largest area. Okay, so if you wanted to, you could do this. You could say these two sides are 6 and 6 meters, and this is 2 and 2. So you created a rectangular fence, but is this the largest area? I mean, this would have an area of 12 meters squared. Okay, let's try another rectangle having a perimeter of 16, because a perimeter needs to be 16 because that's how long the fencing you have. So if I drew a rectangle like this, so if it was 5 and 5, 3 and 3, okay, so that would be 15 meters squared. All right, so we can get a lot of different combinations for the two sides, but we've got to go for the optimal dimensions that give us the maximum area. Okay, so what shall we do? All right, we've got to work out a formula for this. All right, the equation for the perimeter is this. Okay, so if I call this side x, this side would be x as well, whereas this side would be 16 minus 2x divided by 2. Is that right? Yes. Because if these two sides are x, then I would have to add these two sides, and then I would have to subtract it from 16, and that would be the length of these two sides, but each of these sides would be divided by 2. Okay, so that's the length of that side, and that's the length of this side as well. Okay, so my perimeter would be 16. Okay, if I add all of these up, each of these sides, so that's 16 by 2x divided by 2 plus 16 by 2x by 2. If I expand the brackets and add all the variables, I'll just end up with 16. Okay, that's the perimeter. What about its area? Area is simple. You just multiply this times this. So that's x times 16 by 2x divided by 2. That's the equation for my area. Okay, right, so now I've got an equation for its area. Okay, so that's 8x divided by negative x squared. So if I simplify this, I get 8x minus x squared. Okay, so that's 16x minus 2x squared. All of those divided by 2 gives me this. Okay, so that's the equation for my area. Okay, if I were to sketch this, it'll look something like this. Okay, now I've missed out the negative values. Now the y-axis gives you the area, the x-axis is this length of this one side. Okay, so as I change the length of this one side, okay, my area changes this way. All right, okay, so for example, if I make x equals, if I call this side 6, if my x was equal to 6, my area would be equal to 12. Okay, let's see whether that works on the formula. So if I substitute 6 into this, so that's 48 minus 36, that's indeed 12. So if my x was 6, my area would be 12. If my x was 3, my area would be 15. See whether that works in this formula? That'll be if it was 3, that's 24 minus 9. Yes, 24 minus 9 is indeed 15. Okay, right. But there is one particular value for x for which you get the highest area. Now what's that? Okay, now we don't work that out by trial and error. We could differentiate. We could differentiate and find what the stationary point is, and the value for x at that point would give me the largest area. Now let's see what that is. So that's dA by dx. Okay, now it's no longer dy. Okay, this is not a variable described in terms of y. This is a variable a. Okay, so you've got to get used to differentiating with respect to other types of variables. Okay, not just y and x. So that's 8 minus 2x, and at my stationary point the gradient is equal to 0, so that's that. So therefore x is equal to 4. Alright, so when x is equal to 4, that's when I have the largest area. So if I do 4, so I don't substitute into this, I substitute it into this. Okay, this value of x is equal to 4. So if I substitute x is equal to 4 into that equation, I get 32 minus 16, which is 16 meters squared, and that's the largest area that I could get. Alright, so but what dimensions of the fence would I have for this area? So if one side was equal to 4, the other, okay, so let's just work that out. So if this was 4, the other side will be also 4, so I have 8 meters. Remember I told you that I have 16 meters of fencing to play with. Okay, 16 meters of fencing to play with. Alright, so if I make one side 4, the other side will be 4, then I have these two sides making 8 meters, so that means I'll redistribute that equally with the other side, so that'll be 4 as well. So in fact the rectangle is a square. Well, that's true of any problem of this nature. Okay, if you have a long wire and you're trying to create a rectangle with the largest area, the largest area you'll get will be always a square. Okay, so you learned something new today. All right, so the optimal way to arrange this so you get the largest area for a fencing that you have 60 meters of fencing will be if you created a square. Okay, and that'll give you an area of 16 meters squared. Okay, let's look at another problem. Okay, this time you are made to create a fence around your house. Okay, now this is where your house is at. Okay, and next to the river. Okay, so that's the river. Okay, okay, so that's your house and that's a fence. Okay, so the fence has actually 3 sides because the other side is actually a house, so you don't need to put a fence around your garden where it's next to the house because you want to get into the garden. Alright, so that red bit is actually the fence. Alright, so one side is definitely 80 meters, and let's say this time you have a length of 200 meters, okay, worth of fencing to play around with. Okay, and you want to get the largest area. Okay, you want to get the largest area. So what's the largest area that you'll be able to muster out of this 200 meters of fencing that only covers 3 sides? Okay, so let's try and work this out. Okay, so my fence has only 3 sides. All right, and again I'll call this side y and I'll call this side x. So the area for my fence would be x times y, whereas my perimeter would be 2x plus I'm afraid it's not 2x, beg your pardon, it's actually 1 second please, it'll actually be x plus 2y, because I'm only creating a fence that has only 3 sides, so it's x plus 2y. Alright, now my equation for my area, I want to get that in terms of only one variable. Okay, I don't want to have 2 variables to deal with, so I'm going to make now I know what my perimeter is, so my perimeter is 200, so x plus 2y. I'm going to make x my subject, so x is equal to 200 minus 2y. Okay, so therefore a is equal to y times 200 minus 2y. So my equation for my area is just in terms of one variable. Okay, so that's what you need to try and aim for. You might have lots of different variables, but you need to make the correct substitutions and to make the equation that you differentiate eventually have only one variable. Okay, so now that's my equation for my area. Okay, so if I were to sketch this, before I sketch I made a small error there, that's 200y. That area equation for the area is actually a is equal to 200y minus 2y squared. So if I were to sketch this, it looks something like this, 100 and 0. Okay, so that's my area, and again, as my values of y change, this is how my area changes as well. Okay, so again, we're trying to figure out this point here. Okay, the value for y at that point would give me my maximum area. So again, I differentiate with respect to a and y. dA over dy is equal to 200 minus 2y, no, 4y, beg your pardon. So again, I make that equal to 0, so 200 minus 4y, that'll make y equals 50. Alright, so when y is equal to 50, what's x equal to then? To work out the length of my other side, x will be equal to 200 minus 2y, so that'll be 200 minus 100, x will be equal to 100. Okay, so the optimal area that I could optimal dimensions to create the maximum area would be this, where I have one side equal to 50, the shorter two shorter sides would be 50, the longer side would be 100, and that will give me my maximum area. So that would be an area of 5,000 meters squared. Okay, alright, now you get asked this sometimes with these questions as well, that you'd be asked to prove that this value of 50 for y would give you the maximum value, okay, of a. Alright, now you'll have to prove that 50 at y is equal to 50, that this value is indeed a maximum. How would you do that? All what you gotta do is do the second differential. So that's the first differential. If I do the second differential, that's d squared a over dy squared, that is equal to minus 4. So because my second differential is negative, that's indeed a maximum. Alright, so you tend to get asked that also in exams, that the value that you got for y, whether if that's the maximum, prove that it is so. So you do the second differential, and that's indeed a maximum. Okay, because second differential gave you a negative value. Okay, so that's it from me for this chapter. So I'll see you soon for the next chapter. I advise you to go and do some questions on the book, on the Edexcel book. I'll see you soon. Bye bye.